Hello, I'm Rob McManus, a marketing manager at Red Hat. I'd like to explain how a telecommunications service provider's on-premise 5G core can be expanded using a public cloud. When expanding the 5G core to a public cloud, it is important to be able to automatically deploy and scale on demand, while at the same time ensuring performance and reliability. Having a unified platform to host the 5G core, regardless of the environment, is important. And this is important to ensure consistency of experience and operation. So how can the 5G core network functions be moved to the public cloud dynamically and with no service degradation? Let me show you how you can achieve this with Red Hat and our collaboration with partners including Amazon Web Services, Tech Mahindra, i2i Systems, and Ribaka Technologies. The 5G core network functions can be deployed both on-premises and also in a public cloud. The 5G core has a collection of network functions grouped as what we call control plane and also user plane functions. The user plane function performs packet routing and also forwarding between a service provider's network and the internet. The control plane functions handle authentication, registration, and also the overall signaling between devices in the core network. Let's see how the 5G core is deployed. Red Hat Advanced Cluster Management for Kubernetes and Tech Mahindra's NetOps.ai solution are used to deploy a 5G core cluster. Here we're showing the deployment to the Amazon Web Services public cloud. The deployed cluster can be seen from the Red Hat OpenShift user interface as a single pane of glass. Cluster control and worker nodes are activated as is shown here. NetOps.ai uses the previously created cluster to deploy the i2i Systems 5G core. NetOps.ai then creates or instantiates the 5G core on the selected cluster. Red Hat OpenShift is used as a unified application platform for a service provider's 5G core, and that's used across on-premises and also the public cloud. Certified Helm charts for the 5G core deployment are used by NetOps.ai. The 5G core functions can be migrated to a public cloud environment, and this is beneficial for scalability reasons such as data bursting and also service degradation scenarios. Secure connectivity between the 5G core network functions across these different cloud environments is achieved with Red Hat Service Interconnect. Let's now take a look at how a service degradation issue of the 5G core network function can be mitigated. Ribaka Technologies' ABOT test bench is used to simulate network functions and also devices, the G-Node B, and their associated signaling messages. Every device that connects to a network must first register with the 5G core. This is achieved with messages between the device and the 5G core's access and mobility management function. For data transmission to occur, the device has to request a packet data unit session. This is achieved with messages between the device and the 5G core's session management function. We will now simulate the failure of the on-premises 5G core's access and mobility management function. Upon failure, the ABOT G-Node B simulator understands that the primary 5G core is down and starts the signaling message transfer between the device and the failover network function that's deployed on the public cloud. So-called geo-redundancy of 5G core network functions deployed on the public cloud ensure minimal downtime. Our collaborative solution provides automation and also orchestration of a 5G core for both on-premises and public cloud deployments. Automation is needed to adapt to the nuances of the different cloud providers and also environments, changing workloads and operational requirements, scaling resources dynamically to meet demand, and also provide the necessary performance and reliability. To learn more, contact us today.